Maybe you can catch part of the basketball game if we get moving. Okay. We are going to sketch this guy. The secret to sketching is factoring first. So we're going to factor out an x squared. We're left with x minus 2. There are two x-intercepts. There's an x-intercept at 0 and an x-intercept at 2. Now, what's the degree of this polynomial? It's 3. Odd polynomials start down, end up. So, I'm going to start down here. Now, what happens when I hit that point? It bounces. Turns around, comes back up, and passes right through. The direction said sketch, done. Number 23 is a very obscure problem because we haven't talked about symmetry for a long time. And it hasn't really come up, so we haven't talked about it since we did it back in whenever that was, September or whatever. So, you need to remember your rules of symmetry, okay? You need to remember that if something is symmetric about the x-axis, you can change the sign on y and end up with the same equation. Is that the same equation as the original one?
No.
No, so there's no symmetry. To test for symmetry about the x-axis, or y-axis I mean, we change the sign on x. So if you change the sign on x, would that be the same equation?
Yes.
Yes. So we have symmetry about the y-axis. The test of symmetry for the origin, you might recall, is change them both. So if you change the y's to negative and you change the x's to negative, would that be the same equation that you started with? No. And the test of symmetry about the identity line is we switch our variables. Clearly that is not the same equation, right? So this one only has one symmetry and it's about the y-axis. Now, a little hint. I have no idea what equation you're going to be given. But if it's something simple like this one, just think about it. What shape is that? It's a parabola opening up. And its y-intercept is down here at -4. This is what this parabola looks like. Can you tell from the picture that it's symmetric across the y-axis?
Yeah.
Yes. So if it's an easy one, then you don't have to go through all this. You can just say, oh yeah, that's a parabola opening out, vertex at 0, -4, that has symmetry about the y-axis. Okay, next page, here we go. A function is defined parametrically find the point if t equals 0. Well, if you miss this, you are hopeless. It says, let t, seriously, come on, let t equal 0. All right, if t equals 0, then x would be -1 and y would be 3. So your point is -1, comma, 3. All right.
Oh, when you do the square. No, when
Right?
because you put in 0 times 0 times 0, 0. So you still put it in something.
Right, the Cartesian equation is eliminating the parameters. If I am going to eliminate the parameter here, I am simply going to take one of my equations, probably this one, and get t by itself. So this equation would say t equals y minus 3, right? Then I will take this y minus 3 and plug it in right there. So x equals y minus 3 squared minus 1. Now, this is one of the few times you don't have to do anything else. You're done. Because what did the directions tell you to do? Eliminate the parameter. T is the parameter. There's no more T. Moving on to the next question. Graph. Now, to graph this, one option would be to plot points. Now, groupies, do you already know 1 point?
Yes.
And how did you find that point? You put in T equals 0, right? So if I wanted more points, I could put in other numbers for T. So you might think about making a T-chart, literally a T-chart, where you have values of T and then X and Y. So you already did this one. So maybe you let T be 1. And if T is 1, you would get 0, 4. So you go ahead and plot that. And maybe we let T be -1. So that would give us 0, 2. And at some point, hopefully, you recognize something. This is a squared equation, isn't it? What do squared equations look like? Except, what's different about this one? It's y squared. So guess what that does to your parabola? And can you see that happening here, kids? Can you see what's going on? There it is. Now, I'm old, I do this for a living, so that's obvious to me. If it's not obvious to you, you're going to build a few more points, right? But at some point, you're going to have enough points up here that you're going to get it. You're going to see what it looks like. When in doubt, plot points.
When in doubt, plot it out.
Number 25. We're going to solve this. You should all be able to do this. By the way, these questions are all worth the same. So how cool is it we got these easy ones thrown in? How do I solve this? 4 squared equals 3x plus 1. 16 equals 3x plus 1. 3x equals 15, and x equals 5. Solve the next one, the one right next to it there. What do you do with that one? No, you don't do the same thing. It's an entirely different problem. Move the 2 up here. So we have the log base 3 of x equal to the log base 3 of 64, which means x equals 64. These are different problems. That one has 1 logarithm, that one has 1 on each side. They're handled differently. 1 logarithm we translate, rewrite it. 2 logarithms, we drop them out. Sketch. When in doubt, I just told you, if you have to sketch, just plot points. So put in 0. What do you get when you put in 0?
3. 0, 3. No, kidding.
You put in 0, you get 9. What do you get if you put in 1? Oh, it's way up here. What do you get if you put in -1? 3? How about -2? 1. Connect the dots. Is that what you expected to see, a shape that looks like that? Yeah, because this is what kind of an equation? Exponential, and that's what exponentials look like. 27, we're back to the calculator. We're investing compounded annually. Which formula am I going to use? What? Boys and girls, I got me doing it. In a money problem, the only time you will ever use PERT is if it's compounded continuously. Otherwise, if it's money, it's that formula. So we'll put the 987 here. We've got 0.045. What does compounded annually mean? Once a year. How long will it take to end up with 1, 2, 3, 4? Am I going to need logarithms?
Yes.
Yes, I am. So step 1, divide. So 1, 2, 3, 4 divided by 987 equals 1.045 to the t. No sense messing around with that because it's a 1. So we'll just say 1.045. What do I do now? Log both sides. Here we go. The logarithm of this side equals t times the logarithm of this side. Did I do too much at once?
Shoot. No.
If I take the logarithm, the exponent comes out, right?
So then divide.
Now I'll divide. So I'm going to have the logarithm of 1, 2, 3, 4 over 987 divided by the logarithm of 1.045. Just make sure you close these parentheses when you type it in. And it should all work out great. I got 5.074, and that would be years. It's going to take that many years for it to work out. How long will it take 543 bacteria to grow into a population of 8901 if the population increase is 2.3% per day? PERT. Anytime you're dealing with populations, it's PERT. So we want to end up with 8901. We're going to start with 543. 0.023 is R, and we need to know T. Are we going to need logarithms?
Yes.
Not yet, though.
You have to divide.
First, we have to divide. And because this problem has an E in it, let's ln. Not because we have to, but because it's more convenient. Why is it more convenient?
Because they cancel.
Gone. So we have ln 8901 over 543 equals 0.023t. Starting a piece of paper run. I need everybody to sign that paper. And then we're gonna, oh, I need all my students. Well, actually, if you're not my student, go ahead and sign it. I don't know whether, I don't know what the hell that. So we have this divided by 0.023. So my answer works out to be oh my. I got 121.
That's what I got. That's what I got.
0.6. And that would be days. Oh, days. It's going to take it 121 days. Okay, here we go. Now we need our calculators. This is a regression problem. This is where we put in our numbers into the list, remember, in stat? So here we go. Let's look at what we've got. If Nate is 1 minute late, he gets 1 detention. That's an ordered pair. If he is 3 minutes late, he gets 4 detentions. If he's 4 minutes late, he gets 11 detentions. Write a quadratic equation using your quadratic regression capability on your calculator. So we're going to go into our stat menu and we're going to edit. Now, if you already have stuff in there, you can go back to stat, go down to clear list, type L1, L2, and that'll get rid of it. Or you can just manually delete them, or you can just type over them. Whatever's easiest for you. This is L1, there's only 3 points, 1, 3, 4. And L2 is your Y's, so that would be 1, 4, 11. Now as soon as you get those in, hit second quit. Right? Then go back into your stat menu, click over to calc, and go down the list till you get to quadratic regression. Now, boys and girls, could the test have cubic regression on it? Yes. And there will be no difference except you will click down to cubic regression.
Right arrow over the top.
Now, my equation came out to be 1.833 x squared minus 5.833 x plus 5. If you didn't get that, just wait. We'll have to wait. All right, so here's my equation. How many detentions will Nate get if he is 5 minutes late? How would I figure that out? Plug 5 in for x. So I'm just going to plug 5 in. And I'm going to have to round it off probably to the nearest detention. So that would be looks like he's going to get about 22 detentions. What is the minimum number of detentions that he can receive? Well, this is a very bad problem. I made it up totally, as you can see, totally. Nate, by the way, is Toph's brother. It's made up, totally made up. So it's not designed very well for this, but what I want you to understand is, what kind of equation is this? When you do a quadratic regression, what do you get? A parabola. So if you want the minimum, you can either find the vertex doing negative b over 2a, wouldn't that be the minimum? Or you can graph it on your calculator and use the minimum feature of your calculator. This one's not going to make any sense because we all know if he's not late, he shouldn't get any detentions. But he's going to get 5 if he's not late at all. So it's just a bad problem. But what I want you to know is, if you need the minimum, then you'll either do negative b over 2a to find the vertex, or you'll just graph it on your calculator and find the minimum. Got it? Okay. Next, consider the exponential function. Guys, the test is not going to say consider the exponential function. It's going to say consider one of the other 11, right? BFFs, 12 of them. So you need to know them all. I wouldn't say you need to know anything really about them but their shape, because you can answer the questions if you just know the shape. A minute ago, we sketched an exponential. It looks like this. What is the domain? Look at the x's. Somebody said it. All real numbers. Your domain is all real numbers. What is your range? Everything greater than 0. That's your range. Now, do not memorize these. It's going to be different for every BFF. Get your picture memorized, and then you can answer the questions. Would you say that's a continuous curve?
Yes.
Yes. Are there any asymptotes in it? Yes. This is an asymptote. So the asymptote is y equals 0. That's the asymptote, y equals 0. Would you say this curve is increasing or decreasing? Increasing. Increasing on its entire domain. It's going up, 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 up as you move left to right. Would you say it's bounded? Now remember, you can be bounded above, bounded below, or both. This is bounded below by its asymptote, right? Y equals 0. And behavior. This is the tricky one with the wild notation. And behavior. That's the limit as x approaches infinity and the limit as x approaches negative infinity. Now, tell me what happens to the curve as you go this way. As x goes this way, what happens to your y values? Positive infinity. As x goes this way, what happens to your y values? Oh no, your y values aren't going to negative infinity. That would be down here. It's not doing that. What are your y values doing? It's getting closer to 0. Additional exam review. Let's grab a few of these. Find all the asymptotes. We're going to find all the asymptotes.
Wait, are you doing the extrema for that one or not? I have no idea.
Oh wait, I'm sorry, I missed extrema. I didn't see it over there. Back to my exponential. Extrema mean maximums and minimums. This curve does not have any. The absolute value function would have a minimum, right? The quadratic function would have a minimum. So some of them have mins and maxes, this one does not. Okay, now I'm finding all the asymptotes of this. Stay with me, people. We've made a lot of progress. Stay with me. We'll be done soon. Vertical asymptotes. Vertical asymptotes happen when the denominator equals 0. So you have a vertical asymptote at 4/3. Horizontal asymptotes are the tricky ones. You look right here. Where's the horizontal asymptote? Y equals 2/3. Look at the next one. Same type of question. A little bit different problem. Tell me about vertical asymptotes. 2 and -2. There's 2 of them down there. X squared can't be 4, so x can't be 2 or -2, right? Now tell me about the horizontal though. Things are a little wacky here. The power on the bottom is bigger. It means your asymptote is at 0. And if you forget the logic, there's no x squareds on the top to balance this out, kids. You got 0 over 1. 0 over 1 is 0. Anytime the power on the bottom is bigger, your asymptote's going to be at 0. What, Katie?
When is it slanted?
When the top power is bigger, you'll have a slant asymptote when the top power is bigger. Note, there's no slant asymptote on the review. Number 2, find the symmetry. All right, we already went through that, so I'm going to go through it very, very quickly. I need to test for symmetry about the x-axis, the y-axis, the origin, and the identity line. How do I test for symmetry about the x-axis? I change the sign on y. Clearly, boys and girls, this is not the same equation. Y-axis. Change the sign on x's. Now be careful. Sometimes we think this is the same equation, but it's not. Because if I simplify this, I get negative x cubed plus x. That is not the original problem, is it? Origin. Change them both. So that would be negative y equals negative x cubed minus negative x. This looks promising. Because negative y equals negative x cubed plus x. What happens when I divide through by a negative? Don't I get the same thing? So that one has symmetry about the origin. Here I switch my variables again. You don't even need to write that down. You know that's not going to be the same equation. Find the exact value of the sine of 2 pi over 3. Oh my gosh, we better be able to do this. Okay, pi is 180 divided by 3 is 60 times 2 is 120. I'm finding the sine of 120. So I'm going to draw myself 120 degrees. How big is my reference angle? 60. So this is root 3, this is 1, this is 2. Anything negative? The 1's negative. I want the sine. What's the sine? Opposite over hypotenuse, root 3 over 2. There's your answers. We're almost done, guys. Please be patient. This will pay off, I promise. We want to find the y-intercept of all these equations. Okay, so we'll start with these three. How do we find a y-intercept, people? Plug in 0 for x. Whoa, 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 whoa. 9. No y-intercept. You can't plug in 0 for x. Boys and girls, you can't sit on the egg, as Mrs. Hollis is fond of saying. You can't put a 0 in the denominator. Okay? Now, let x be 0. What do we get? Negative 3. Let x be 0. Okay, this one takes a little more patience. I think that's a time sign. Takes a little more patience. We have 12 over 1 plus 8 times. What's 3 to the 0? 1. So we have 12 over 9, which is 4/3. So your intercept is 4/3. There's a couple more. There's a lot of y-intercept on the exam. Now, this looks scary. Don't you dare be confused. How do you find a y-intercept? Kids, I don't care what kind of equation you have. Doesn't matter. How do you always find a y-intercept? You let x be 0. So I'm going to come right up here and I'm going to let x be 0. What does that tell me? T equals 3. If t equals 3, what's y? 11. What's your y-intercept? 0, 11. That's your y-intercept. Kids, I cannot say it enough. To find the y-intercept, you let x be 0. Regardless, you let x be 0. Okay, maybe you can do E without writing it down. If you let x be 0 in E, what do we get? Negative 12. Negative 12. If we let x be 0, we get negative 12. Okay. Now we are finding the vertices. We are on 5. We're almost done. We're almost done. I promise you're going to be glad you have endured this. All right, what's the vertex? What's the vertex? -1, -3. This one is in vertex form. So the vertex is -1, -3. This one is sort of in vertex form. We could make it vertex form by adding 3 to the other side. What's the vertex? -5, 3. This one isn't even close to vertex form, but we talked about it before. To find the vertex, one option we have is -b over 2a, which would be 3/2. Right? And then we're going to plug 3/2 into our equation. So we will have 2 times 3/2 squared minus 6 times 3/2 plus 1. No whining. 2 times 9/4, which would be 9/2, minus 18/2, which is 9, or maybe I'll just leave it 18/2. That might be a good idea. Plus 1, which is 2/2. So what do I get? -7/2. Just a couple more problems, and you are free to go do whatever you do on Friday night. Find the remainder. Find the remainder. I would just divide it. Now, one word of caution. Because our job as teachers is to mess with you as much as we can, be careful. Make sure there's no zeros needed in that line. There aren't on this problem, but there might be on the exam. Remember, all the powers have to be there. All right, so we drop the 4 down. That's -8, 0. That's 0, -4. That's 8. That's 9. Did I do that right?
Yes.
So the remainder is 9. This next one, I need you to pay attention here. This is not at all hard. I need you to pay attention. Okay? Find the intervals where the curve is decreasing. Now, you all know what decreasing means. Decreasing means going down. So clearly, it's not decreasing here or here. Would you agree that it's decreasing there and there? The answer to the question is the x values where that happens. So where does the decrease start? At -1. Where does the decrease ultimately end? 1. There is your answer. The interval from -1 to 1. Now let's do the increasing just to make sure you can. Where would the increases be happening? From -2 to 1, or -1 I mean, and then again from 2 to 3. And when we link together intervals, we use the U for or, the union symbol. And finally, this should have a, oh no, never mind. Finally, we want to find the sine of the acute angle. What does acute mean? Quadrant 1. The tangent is 1/3, which means the hypotenuse is √10 because of the Pythagorean theorem. I want to know the sine. What would the sine be? 1/√10 or √10 over 10. Beautiful. 7:59. We are awesome.
Wow. That was awesome.